Here we go, podcast for chapter 6.1 through 6.3 this Friday, January 18th, 2013. See, we go through each slide here. Down at the bottom, I do have the name of the section. So as you can see here, constellations. So as you're looking at your study guide, you're going to want to look for each of these sections. Each slide will be over each of the sections that we've broken this down into. What is a pattern or group of stars? That's going to be a constellation. Next up here, rotation versus revolution posters. How long does Earth take to revolve? 365.25 days. Some of these I'm going to go through fairly quickly. You can pause as you need to, but there's not a whole lot of discussion that we need to go through. What causes the constellations to appear to move? It's going to be as Earth revolves around the sun, we have a different view of the stars, and that's going to be the stars, especially along the ecliptic, the path that the sun and all the planets are found on in the sky. Those constellations that are around Polaris are going to be there all year. They're going to be in different places, different spots in our sky as Earth rotates, but they stay. How long does Earth take to rotate? 24 hours. What causes night and day? And also, what causes the sun and moon to move across the sky? Both of these are going to be Earth's rotation on its axis. Okay, next slide here is 'tis the season. Why does Earth have seasons? Remember, it's twofold. It's not just our revolution as we move around the sun, but it also is our tilted axis. What occurs when neither hemisphere is pointed towards or away? Well, we've talked about this previously. They are equal. So in that case, we look at the beginning of equinox here, and we can see the EQU, so equinox and equal. What months are the southern hemisphere in winter? Well, they're just the opposite of us. So they're going to be in June through September. And it's because they are tilted away. Let me fix my mark here. They are tilted away from the sun. Where do the direct and indirect sun rays strike Earth in each season? Again, this is something that your study guide brings up, and this is something that you can work through. So each month is available on here, and you can see December, March. Make sure I have the right color here. December, March, June, and September. So you're going to want to draw these four. And you can see in the picture over here that it places Earth at 4 different spots. And the 2 equinoxes, which are here and here, of course, the rays are landing the same. So they're equal, hence equinox. And so here we have summer for us. And this is going to be, of course, winter for us. So when you look at the picture and you start to think about how you're going to mark this on the back of, so in December, direct rays are going to be here. In the summer, direct rays are going to be here. And as we already talked about with the equinoxes, spring and fall, they're going to be equal. They're going to be directly at. So as you're drawing this, this one needs to be your direct, this needs to be your direct, and then just the opposite here. This should be your indirect for the winter, and your indirect for our summer for the southern hemisphere's winter. So as you go through, draw each of these, put them on the back, mark up where the direct and indirect rays take place. Okay, gravity and motion. What causes all objects to be attracted to each other? It's the force of gravity. What does the strength of gravity depend on? That's going to be the masses of the objects and the distance between them. So, for instance, Jupiter, much more massive than Earth. Its strength of gravity much higher. But Jupiter's gravity, as great as it is, won't have an effect on an object that is out towards the outside of the solar system. It's too far away. So you could have something that has high mass, but if another object's too far away, it won't affect it. So you have to have the mass of the object and the distance between them, both of those together. Inertia is the tendency of a moving object to continue moving in a straight line or a stationary object to remain in place. It's the reason why when your parents stop quickly in the car, anything that is loose in that vehicle continues going forward. And it's also the reason why wherever you put your homework last night, it's going to stay there. It's not going to move. Inertia keeps your homework in the same place unless a force acts on it, and if you lose your homework, it's usually you that was the force that acted on it. Two factors that keep Earth in its orbit, gravity and inertia. Gravity, so as we look, for instance, we draw the Earth, and then I'm going to add the moon, just as a very simple example here. Gravity is going to pull the moon towards the Earth. Inertia wants to keep the moon going in a straight line as it moves around. Gravity keeps pulling it in. So the equal of these two would be then the orbit that the moon ends up taking around the Earth. So gravity and inertia. Inertia wants to keep it going into space. Gravity wants to pull it into Earth. Thank goodness it equals out, and therefore you have an orbit. What does Newton's law of universal gravitation state? It states that every object in the universe attracts every other object. Everything that has mass, everything also has gravity, even you. Okay, practice questions in the book. You can see our list up here, 2 pages, 217 and 219. Quite a few good practice questions. I would highly suggest you go through those, put away your study guide, and see if you can answer them without any help. Okay, finally, podcast is ended. Don't forget to take the practice quiz. Make sure if you have any questions about anything on that study guide, make sure you see Mr. Cora or Mr. Windmiller.